This video will be on how to divide algebraic fractions. So before we look at how to divide algebraic fractions, the best thing to do would be to revise how we divide regular fractions. And some of you may remember a little saying that makes it quite easy to remember, which is keep, change, flip. Keep, change, flip. Okay. Keep, change, flip just means keep the first fraction the same, change the division sign to a times, and flip the second fraction. And when we say flip, we're really asking you to write down the reciprocal of that fraction. The reciprocal just means to interchange the numerator and the denominator. Flip would probably be the more casual way of saying it. So we're going to keep the first fraction the same. We're going to change the division sign to a times sign, and then we're going to take the reciprocal of the second fraction. That means move the denominator to the numerator and the numerator to the denominator. That's this fraction here is called the reciprocal. Now it just turns into a regular multiplication question. And for multiplication, we are allowed to cancel diagonally, and we are also allowed to cancel vertically. So we've got to look and see, can anything cancel? Well, I can already see that the highest common factor of 33 and 22 is 11. 11 will go into 22 twice and into 33 three times. I can also see that there's a common factor of 4 with the 8 and the 12. 4 will go into 8 twice. 4 will go into 12 three times. And then when I check vertically and diagonally, I can't see anything else that can cancel. When you get to that point where nothing else will cancel, you will multiply whatever's left. So in the numerators, I have 3 3s. It gives me 9. And in the denominators, I have a 2 times another 2. That gives me 4. So that is how we divide regular fractions. Now let's look at an example with algebraic fractions. So don't forget our 3 steps. Keep the first fraction the same, change the division sign to a times, and flip the second fraction. So we're going to keep the first fraction the same, change that division sign to a times, and flip my second fraction. And then I'm checking for cancelling. I can see some cancelling already. I can cancel out a G here with a G diagonally opposite. I can also see that 5 and the 10 have a common factor of 5, so 5 goes into itself once and into 10 twice. Notice how I'm cancelling. I'm not scribbling anything out. I'm just drawing a single line through. So once I finish cancelling, I can try and multiply whatever's left. So let's have a look what we've got. I'll get my little highlighter out. I've got a 2. I've got another 2. I've got an H here. I don't have to worry about ones. I won't highlight that one because anything multiplied by 1 will remain unchanged. So really that's all I've got. So if I multiply the numerators, well, 2 2s are 4. And if I multiply the denominator, all I have in the denominator is that H over here. So I will just write the H down the bottom. And that is my final answer. So what do I do when my second term is not a fraction? Well, you've got to remember that every whole number or every term, so if I have the number 7, that's exactly the same as 7 on 1. If I have the pronumeral a, that's exactly the same as a on 1. If I have 5q cubed, that's exactly the same as 5q cubed over 1. Every single term can be written over 1. So I do in fact have a fraction. So now I'm going to follow those steps again. I'm going to keep, I'm going to change, and I'm going to flip. Now I can check if anything can cancel. So I can see already that if I remove, say, these m cubed, a string of 2, then I need to take a string of 2 out of there. And what I can do is either just cancel the power out completely, or if you want to be super clear, you can write a 1 there, because if I take 2 of the m cubed m's out, so I've got m times m times m, if 2 go, then I've got 1 left. I can also see that 3 and 9 have a common factor of 3, so 3 goes into itself once and into 9 three times. And then if you've got a highlighter, you might say, okay, I've got that 3 there, I've got an m, I don't need to highlight 1, I've got a 17, I think that's all I've got. Everything else has a line straight through it. That's why I've got to be very clear with my lines. So really what I must have is 3m all over 17. Lucky last. I think we're in a real swing by now. So if you're feeling confident, I would pause the video and do this without me, and then you can play it and see that. Check your answer with my answer. So let's go for it. We're going to keep, change, flip the second fraction, and then I can start my little cancelling. So what have I got? Pretty sure 13 goes into 26, and I'm pretty sure there's a common factor with 30 and 12. Let me just write that 30 clearly. So I might change my pen colour. I'll make it red. Yeah, that works. So 13 goes into itself once, into 26 two times. Now the highest common factor of 30 and 12 is, don't say 2, it's 6. 6 will go into 12 twice, 6 will go into 30 5 times, and now I get to think about pronumerals. An a in the top is an a cubed in the bottom. Let's remove that a, and then we can change the cubed here to a squared. And let's get rid of that whole b, and we can change the squared to a 1, or just cross the power out. Now in terms of what I have left, what can we do? Stand out. I've got a 5, I've got a 2, I've got a b, crossed, got a 2 here, got an a, and I have a squared. So let's put all that together. In the top I've got 5 2's. Well, 5 2's are 10, followed by a b. And in the denominator I have a 2, I have an a, and I have a squared. So that would be my final answer.